deep in the outer reaches of the solar system, so far away from the known planets that the sun would barely be distinguishable from a nearby star. A massive, icy world may be lurking in the shadows, waiting to be discovered by humanity. Dubbed Planet 9, this hypothetical celestial body has been the subject of intense scientific debate and speculation since its existence was first proposed nearly a decade ago. Some researchers believe it might have been a rogue planet captured by our sun's gravity, while others think it could have formed from the same disk of gas and dust as the other planets. If Planet 9 exists, it is believed to be 10 times more massive than Earth and orbit the Sun at a distance of 400 to 800 astronomical units, which is 400 to 800 times the distance between the Earth and the Sun. Astronomers have been eagerly hunting for clues, using powerful telescopes and advanced computer models to track its influence. After years of watching the sky, solving mathematical equations, and running complex computer simulations, they now have the strongest evidence yet that Planet 9 really exists. This discovery introduces an exciting plot twist in the story of the hidden planet. Join us in today's episode as we dig deep into the enigmatic Planet 9, as well as compelling evidence supporting its presence. The Planet 9 hypothesis. The idea of a ninth planet in the solar system was first seeded by the discoveries of Uranus in 1781 and Neptune in 1846, more than 3,000 years after the other planets were first spotted by the Babylonians. These discoveries proved that the solar system was much larger than humanity had once thought and raised the possibility that other worlds were waiting to be discovered. But other than the now demoted Pluto, no full-fledged planets beyond Neptune or the Kuiper Belt, a massive ring of asteroids, comets, and dwarf planets that orbit the Sun beyond Neptune, have shown up since. And as astronomers mapped more of the outer solar system, it seemed increasingly unlikely that they were missing something as large as a planet. However, a 2004 discovery changed that. Scientists found that Sedna, a potential dwarf planet located beyond the Kuiper Belt, had a weird orbit around the Sun. Its unusual trajectory hinted that another large mass in the outer solar system was gravitationally pulling on the mini-world. But without more information, this hypothesis was hard to prove. Then, in a 2014 study, astronomers announced that they had detected a smaller object in the Kuiper Belt, named 2012 VP-113, with an eccentric orbit similar to Sedna's. The findings also hinted that more eccentric trans-Neptunian objects, known as TNOs, were waiting to be found. These findings caught the attention of Mike Brown and fellow Caltech astronomer Konstantin Batygin, who noticed that both Sedna and 2012 VI-P113 had the same kink in their orbits. This shared irregularity, which causes the objects to briefly dip below the known planet's plane of orbit, suggested that something, such as an asteroid clump, a dwarf planet, or even a full-fledged world, was tugging on these objects. But even after the pair realized a ninth planet was possible, they decided to sit on their findings until they could come up with another, less controversial explanation. However, they then found 4 more TNOs with matching misshaped orbits, which suddenly made a missing planet look like the most logical explanation. At the time, the duo calculated that there was just a 2% chance that all 6 TNOs they had studied shared their orbital oddities thanks to random chance. So, in 2016, Brown and Batygin published their Planet 9 hypothesis, which has captured the public's imagination ever since. The hunt for Planet 9. Since 2016, Brown, Batygin, and others have continued the hunt for Planet 9. Although they have not found it yet, they have discovered even more eccentric TNOs, bringing the total to 13 and further strengthening the case for Planet 9. These discoveries also constrain Planet 9's potential size, its distance from the Sun, and its orbital trajectory through the solar system. Our best estimates are that it's about 7 times more massive than Earth, or anywhere between 5 and 10 times the mass of our planet. This would make it the fifth most massive planet in the solar system, behind Jupiter, Saturn, Neptune, and Uranus. Planet 9's composition is probably most like Neptune due to its distance from the Sun. That would put its diameter at something like 2 times the width of Earth. Some scientists have also suggested Planet 9 could be surrounded by moons, just as the hefty gas giants are. If it exists, Planet 9 is likely around 500 astronomical units away from the Sun on average, meaning it's 500 times farther from the Sun than Earth is. This may sound distant, but similarly sized exoplanets have been discovered orbiting alien stars at equally massive distances, showing that this is possible. This far out, it could take between 5,000 and 10,000 years for Planet 9 to complete a single trip around the Sun. Its orbit is probably highly elliptical, so its distance from the Sun would vary widely over time. It also likely does not orbit on the same plane as the rest of the planets, which makes it even trickier to find. Planet 9's unusual orbit and extreme distance from the Sun also raise the possibility that it could be a rogue planet, an interstellar world that was captured by the Sun after being ejected from its star system. However, Brown and Badigan believe Planet 9 likely formed alongside the other planets in the solar system. Why haven't we found it? But if Planet 9 does exist, where is it? Why haven't we spotted it yet? The short answer made by scientists is that the hidden planet is very, very far away. Light reflected off the planet would be very dim by the time it traveled across most of the solar system twice, which makes it all but impossible to see. Initially, the researchers also had no idea where the planet was along its predicted orbital path. That means they've had to study a huge region of the sky to look for this faint body, akin to trying to find a single white whale in an ocean. So far, researchers have analyzed thousands of images from multiple sky surveys along Planet 9's proposed orbital pathway, looking for objects that move over time. Unfortunately, the night sky is teeming with bright moving objects, such as comets, so the researchers have to sort through a lot of garbage to find the planet. In their most recent work, Brown and Badigan analyzed data from the Panoramic Survey Telescope and Rapid Response System, or PAN-STARRS, at Haleakala Observatory in Hawaii, and confidently ruled out around 78% of the suspected orbital pathway as possible hiding places for the planet. This narrowed down Planet 9's location to somewhere in the most distant 22% of its orbital pathway. Unfortunately, telescopes like PAN-STARRS are not powerful enough to properly search this space. When will we find it? That means if Planet 9 is hiding in the most distant reaches of its orbit, we'll need a telescope powerful enough to spot it. Brown and Badigan have already begun analyzing data from Japan's Subaru telescope in Hawaii, which has a better chance of finding the planet than PAN-STARRS does. But if this survey fails to complete the job, they will turn to the forthcoming Vera C. Rubin Observatory, which is currently under construction in Chile. This ground-based telescope, which will be equipped with the world's largest digital camera, will let researchers peer farther into the solar system than any of its predecessors allowed, similar to how the James Webb Space Telescope has enabled researchers to look farther across the observable universe than ever before. The observatory is currently slated to open in late 2025. With the help of the state-of-the-art telescope, Planet 9 could be found within the next 2 years. However, in the worst scenario, if the telescope cannot find the planet within the first few years, then the hypothesis is pretty much dead. But scientists also pointed out that even if the telescope does not find the planet immediately, it could still identify more TNOs, which would help show if the theory is viable. Why does Planet 9 matter? After all, while scientists remain divided over Planet 9's existence, one thing they all agree on is that actually finding the elusive world would likely be the biggest solar system discovery of the century. It would be a remarkable find. It would also be huge for our understanding of the solar system's origins and evolution, he added. Indeed, observing the planet could also teach us more about the formation and evolution of giant planets. This would not only help us learn more about planets in the solar system, but also shed light on thousands of giant exoplanets around distant stars. If space agencies like NASA send probes to fly close to the planet, they could also reveal more clues about the solar system's past. It'll have many secrets that will be unlocked by studying it in detail. How could humans make the trip to Planet 9? But if space agencies like NASA want to send a probe to visit the distant world, they first will have to plan and get approval for such a mission. And this, according to Andreas Hein, a space systems engineer at the University of Luxembourg, will take at least a decade or more. This is mostly because missions have to go through a lengthy and rigorous government selection process, he added. But this process could be sped up depending on how odd the world appears in initial readings. As Manasvi Lingam, a theoretical astrobiologist at the Florida Institute of Technology, said, if Planet 9 is anomalous in some respect, there could be more interest in expediting such a mission. It is also possible that a private space exploration company, such as SpaceX, could launch missions sooner, potentially as soon as 5 years after discovery, because they are not hindered by as much bureaucracy. How long would it take to reach Planet 9? And once a probe is sent to Planet 9, the next question is how long will it take to arrive? In 2022, Hein Lingam and part-time astronomer Adam Hibbard attempted to answer this question in a theoretical paper that was posted to the preprint database Archive. In this paper, which has not been peer-reviewed, the researchers estimated that it would likely take between 45 and 75 years for a spacecraft akin to NASA's Voyager probes to reach Planet 9. These calculations were based on the assumption that Planet 9 is around 400 astronomical units from the Sun on average, or 400 times farther away from the Sun than Earth. That's also around 13 times further away from the Sun than Neptune, the farthest known planet in the solar system. But subsequent studies suggest that Planet 9's true average distance from the Sun is actually closer to 500 astronomical units. And the most recent survey, which narrowed down the elusive world's potential hiding place, also hints that the planet could currently be more than 550 astronomical units away, near its farthest point from the Sun. However, these developments don't dramatically alter the timeline laid out in the 2022 paper. Because after all, the team's estimates were conservative, meaning that the upper end of their uncertainty range still seems tenable. On the other hand, although 75 years may seem like a long time for a one-way trip, this is quite fast compared to the journeys of existing probes. For example, Voyager 1, the most distant spacecraft from Earth, has been traveling through space for 46 years and is only around 163 astronomical units from Earth. As a result, a Planet 9 probe would have to travel around 3 times faster than Voyager 1 to reach Planet 9 in the researchers' time frame. This may seem unlikely, but it is possible. Probes traveling toward the outer solar system must be gravitationally slingshotted around the Sun, planets, and their moons to propel them across the vast distances involved. Voyager 1's trajectory was carefully planned to allow it to fly closely past Jupiter, Saturn, Uranus, and Neptune, as well as some of their respective moons. To do so, Voyager 1 had to also be slingshotted around objects to slow it down and redirect it to where it needed to go. However, a Planet 9 probe could go as directly as possible straight to the mysterious planet, allowing it to pick up more speed and travel much further in the same amount of time. Mike Brown, an astronomer at Caltech who co-proposed the Planet 9 hypothesis in 2016, originally estimated that a probe could potentially get to Planet 9 in as few as 20 years using a similar method. But it obviously is too difficult to see how a probe could get to Planet 9 this fast using current technology. But it might be possible to reach Planet 9 quicker if we could crack more advanced propulsion technologies, such as light sails, giant sails that catch sunlight, or lasers to accelerate spacecraft. The researchers suggested previously that a light sail could take as little as 7 years to reach Planet 9. However, it could take at least 20 years for light sails to become a reality, the team estimated. Thus, if we found Planet 9 tomorrow, it would be better to send a current probe than to wait for alternative technologies to become available. In short, as propulsion systems advance further, it may also be possible to send people to Planet 9, but probably not anytime soon. After all, as you see, our own planet represents a tiny fraction of the peculiar phenomena that can be found lurking throughout the cosmos, and every day astronomers turn up new surprises. Here are some of the most outlandish objects in space. 1. The Red Rectangle Nebula. Throughout the galaxy, gas clouds take on weird and wonderful forms, but one nebula in particular is baffling astronomers with its oddly geometric shape. Located in the constellation of Monoceros, the unicorn, the Red Rectangle Nebula sits 2,300 light-years away. Its distinctive shape could be due to the fact that 2 stars sit at its heart. If shockwaves from both stars hit a dusty ring surrounding the pair, they could create 2 cones of bright dust. Seen together, these 2 cones look like a square. To add to the mystery, the nebula also exhibits a rare phenomenon called extended red emission, where its dust glows eerily red. It isn't known exactly what causes this, but some researchers argue that it's due to intense ultraviolet light from the stars interacting with carbon-rich molecules in the dust. 2. Galaxy X. Astronomers are good at finding new objects by spotting their effects on their more conspicuous neighbors. Neptune was discovered thanks to its influence on Uranus. Black holes show themselves by the stars they bind into orbits around them. So when astronomers saw odd ripples in the disk of the Milky Way in 2009, thoughts naturally turned to some unseen disruptor. In 2015, they found the culprit, a dark dwarf galaxy orbiting the Milky Way, subtly altering the motion of our galaxy with its gravitational pull. We can only see this galaxy thanks to 4 bright stars that shine out of the gloom. Otherwise, the galaxy lurks in the shadows. To be this hard to see, Galaxy X must be largely made of dark matter, the invisible glue that binds galaxies together. In normal galaxies, this dark matter is peppered with visible stars and hot gas strung out like Christmas lights. But in Galaxy X, it's as if all the lights have gone out. In 2016, a Milky Way-sized galaxy, known as Dragonfly 44, was found to be made of 99.99% dark matter. It joined Segway 1, a dwarf galaxy discovered in 2006 that subsequent observations showed contains 1,000 times more dark matter than ordinary matter. That compares to a ratio of around 20 to 1 in our own Milky Way. Little is known of the origins of these ghostly galaxies, but studying them may help us to understand what dark matter itself is made of. 3. Elst Pizarro. Normally, it's easy to tell asteroids and comets apart. Asteroids are solid lumps of rock and metal, capable of careering into planets and killing dinosaurs. You typically find them in the inner solar system, particularly in the asteroid belt between Mars and Jupiter. On the other hand, comets are icy bodies that form on the outskirts of the solar system. On their rare forays towards the sun, their frozen bodies react with solar radiation to create spectacular tails. However, an object known as Elst Pizarro refuses to be so neatly pigeonholed. When it was first discovered in 1979, its orbit in the asteroid belt led to it being classified as an asteroid. But when it was examined more closely in 1996, it showed itself to have a tail, like a comet. Astronomers first thought that the tail was debris from a collision, rather than something bestowed by the sun's heat. But the tail's brightness and structure changed over time, pointing to an ongoing process rather than a one-off event. The object's rapid rotation, completing a full spin in just 3.5 hours, also said Comet. However, one possibility is that a collision has exposed some subsurface ice on the body, which is slowly being lost to space. In this case, Elst Pizarro would be an asteroid masquerading as a comet, until it has shed all of its exposed ice and gone back to being a standard asteroid again. Arguments still rage between astronomers. To settle them once and for all, space scientists had hoped to launch the Castalia spacecraft for a closer look in 2028. However, the mission failed to get the green light in the European Space Agency's 2016 round of funding, so the disagreements continue, for now at least. Four, Tabby's star. Oumuamua isn't the only object that has got people talking about alien technology. Extraterrestrials have also been implicated in the mysterious dimming of Tabby's star. Located nearly 1/500 light-years from Earth in the constellation Cygnus, it is named after the astronomer Tabitha Boyajian. She was the lead author of a 2015 study which showed that the star occasionally rapidly drops in brightness by a whopping 22%. The star's overall brightness has also been seen to fade more slowly over several decades. The short-term variation was picked up by the Kepler Space Telescope, whose job it was to find alien planets by analyzing the light of distant stars, looking for dips in their starlight as a planet passed in front of them. However, unlike the dimming of Tabby's star, the dimming caused by planets is evenly spaced. As it happens each time the alien world completes an orbit and is also relatively small, normally under 1%. That, as astrophysicist Dr. Eva Bodman at Arizona State University said, makes Tabby's star just keeps getting weirder and weirder. So what else could be dimming the star? One idea is that a swarm of comets is plunging into the inner regions of the star's solar system, producing huge amounts of dust in the process. It's this unevenly distributed dust that might be preventing some of the star's light from reaching us, causing the rapid brightness changes. But that wouldn't explain the other pattern of long-term dimming over decades. Comet dust dissipates in just a few months. This has led others to claim that the culprit might be megastructures built by advanced aliens to harvest the star's energy. If this technology was unevenly distributed around the star, it would cause sporadic dips as it orbited, and it would also block more light over time as the project was constructed, explaining the longer-term fading. But this is a notion that Bodman rejects. She points to observations of the rapid dimming that show more light is blocked at the blue end of the spectrum than the red end. Blue light has a shorter wavelength, so this is exactly what you'd expect if it was being scattered by small dust grains. However, analysis of the light spectrum linked to the longer-term dimming implicates larger dust grains. Therefore, we might be looking at a complex cloud of different-sized dust grains, blocking varying amounts of light as its orientation changes over time. Regardless, the source of all that dust still remains a mystery. The long-term variations of Tabby's star can be traced back to at least the 1890s. Dust shouldn't persist over such timescales, so it seems that some process is replenishing the dust as it's transported away by the outward pressure of the star's light. In short, there's no obvious explanation for what's going on. 5. FRB 121 Note 2. Of all the things leaving astronomers scratching their heads, fast radio bursts, or FRBs, are particularly vexing. As their name suggests, they are sudden, rapid chirps of radio waves, often lasting mere milliseconds. The first one was picked up by our radio telescopes in 2007, and we've been scrambling to try and explain them ever since. These FRBs appear to be coming from outside the Milky Way, often hundreds of millions of light-years away. To be seen from such a distance, they must release as much energy in a fraction of a second as the Sun does in 80 years. Explanations range from colliding black holes to signals from extraterrestrial civilizations. But before astronomers had managed to figure them out, the universe threw us another curveball. A burst known as FRB Tonsil 112, emanating from a small galaxy 3 billion light-years away, was seen to repeat. On just one day in August 2017, it repeated a staggering 93 times, ruling out a single event as its cause. Whatever triggered the burst had to be ongoing. So maybe FRBs are caused by rapidly rotating neutron stars, or material continuously falling into black holes. Of course, FRB 12112 could be a red herring. There could be two separate causes of repeating and non-repeating FRBs. In October 2018, a new haul of 19 non-repeating FRBs was announced, including the closest and the brightest FRBs detected to date. Studying their properties should help us to pin down their home galaxies, and ultimately, we hope, the cataclysmic processes that are causing them. 6. Hoag's object. We live in a flat spiral galaxy known as the Milky Way. Other galaxies, called ellipticals, are shaped like rugby balls. But Hoag's object appears to be neither. It has an older yellow core surrounded by an outer ring of young blue stars. But in the middle, nothing. It's like something has swept away the spirals. There's no other galaxy in the universe quite like it, and astronomers are stumped as to how it formed. It was spotted in 1950 by American astronomer Arthur Hoag, and perhaps the most feasible explanation offered so far is that 2 to 3 billion years ago, a small galaxy sped through the larger disk-shaped galaxy, creating this unusual structure. But there's no sign of any galaxies nearby that might have served as the bullet, and such a collision would have sped up the core of Hoag's object, whereas observations show that it spins slowly. To add to the conundrum, if you look closely at roughly the 1 o'clock position, there's a smaller version of the galaxy hidden within itself. 7. The Bermuda Triangle of space. Imagine drifting off to sleep when, still with your eyes closed, you're suddenly startled by an intense flash of light. This is exactly what some astronauts have reported when passing through the South Atlantic Anomaly, or SAA, a region of the Earth's magnetic field also known as space's Bermuda Triangle. Scientists believe it is linked to the Van Allen radiation belts, two rings of charged particles trapped in our planet's magnetic grasp. Our magnetic field is not perfectly aligned to the rotation axis of the Earth, which means these Van Allen belts are tilted. This leads to an area 200 kilometers above the South Atlantic where these radiation belts come closest to the Earth's surface. When the International Space Station passes through this area, computers can stop working, and astronauts experience cosmic flashes, probably due to the radiation stimulating their retinas. Meanwhile, the Hubble Space Telescope is unable to take observations. Further study of the SAA will be crucial for the future of commercial space travel. That's all the information that we have for you today. Don't forget to give us a thumbs up if you enjoyed today's episode, subscribe if you haven't already, and hit the bell so you never miss out on future episodes. And be sure to also tell us what you think about today's content. Everyone's support motivates us to continue delivering quality content and to always improve. As always, thanks for watching, and we will see you next time.